Here we're looking at the definition for what is the vertical line test. But before we kind of dive into that, let's kind of look at this side example. As you guys can see, I've already kind of labeled a couple of just random points, and we're just kind of first determining, is this in fact a function or not? Well, this 4, we don't see any other 4s. This 1, we don't see any other 1s for our x's, so they're good. They're checking out. We end up then with this third guy. He has 2. Are there any other 2s? Yes, there are. We can see that they are in fact going to 2 different y values. But, so as a result, you should be thinking to yourself, this is not a function. So not a function. But let's talk about graphically what's going on there. So in other words, let's go ahead and just graph these different points. We have 1, 2, 3, 4, -1. There's that point. Then we have this other one, 1, 3. These guys weren't really giving us too many issues. Then we get to this point 2, 5. So 2, 5, which is right here. And then this other point 2, 2. So at that same exact x value, we end up with a different y value. The vertical line test pretty much just says if you can cross 2 points vertically, then that is not a function. And again, that is what really caused, these 2 points were what caused that issue. We can see that that vertical line is crossing between those 2 points. For this guy, if he did the vertical line test, hey, it would have only crossed 1 point. This guy would have crossed only 1 point. And that's okay. It's when you see this double crossing like this, it's not a function immediately. So you can actually stare at a problem and literally take half a second to determine yes or no if a function is or not, if a graph is or not a function. So in other words, for our formal definition for the vertical line test, it's also known as the pencil test. So you could literally put your pencil on the piece of paper. So if it only touches once, you're good. But our formal definition for the vertical line test is simply drawing a line, a vertical line, anywhere on the graph and if it intersects more than once, then it is not, then the graph is not a function. If it only touches once every single vertical line test, then it in fact is a function. Now, why again does this work? Well, if you go back to the definition for what a function is, it's simply for every input. That's weird. There we go. For every input, we should end up with an output for each. We should probably just say more specifically for each input, we should end up with an output. Okay. So in other words, kind of how that relates with our graph here is we have this input, he went to an output. We had this other input, 4, went to an output. We had this input 2, it went to this output 2, but it also went to this other output 5. That can't happen. So for each input, we should end up with an output. So in other words, example 4 is just saying, are these in fact functions or not? Well, doing that vertical line test, is it only crossing one time? Yep, there's just crossing once. Yep, there's just crossing once. Yep, there's crossing once. Once, once, once. This should happen throughout the entire graph. So is this first one a function? The answer is yes. When we're looking at the second guy, is it a function? No, crossing twice. Is this a function? No, crossing twice. So as a result, even it just takes one time, really, so you didn't even have to do the second test. But that's what will determine a function or not, that vertical line test. This guy, touching twice, not a function. This guy, touching once. Yep, this is a function. Alright. So again, though, that is the definition for the vertical line test. It's a very nice, quick way to kind of just determine a function graphically or not. Okay? And also example 4.